45, 45, 90 triangles. Why is this triangle so special? Well, there's a couple reasons. One, 45 degrees is half of 90 degrees. So that's something that we see fairly often. Right angles are very common. And so cutting them in half would be something that would be likely to, happen. In addition to that, since these base angles here are congruent, well, that means these are congruent as well. So this is actually an isosceles triangle. And in fact, it's the only isosceles right triangle. So that's kind of why it's important. And we end up with this nice relationship here that this is kind of the key. And you'll see that there's two keys because it's isosceles. Whatever the legs are, if you just multiply that by the square root of 2, and we get that from the Pythagorean theorem, we get the hypotenuse. So that works out pretty easy here. Here's what I'm going to do. I'm going to show you two examples of how we can apply this. The first one's pretty easy. The second one's a little tougher. So once again, it's that idea that we're looking for the key. Now, when we're using a formula, though, it tends to be pretty easy to just transfer everything from that diagram over to our new diagram. And then hopefully that'll allow us to find the key. So in this problem, we see that the two legs are the same. So I can call these both A, and then the hypotenuse is a square root of 2. So y is just going to be a times the square root of 2. So our goal is to find that key, to find a. And you know what? We already did. We know that the value of a is just 4. So that means that x is equal to 4. And that also tells us that y here, we can just substitute in 4 for the a and multiply it times the square root of 2, and we're done. That's the beauty of this. It's super quick. It's super easy. So let's look at one more example and apply that method one more time so you can see it again. This one's a little tougher, but it's not that hard. One other thing I'm going to point out is that we have a as our variable for our example here, our formula. But then they're using a in this problem here. So all we need to do there is just pick a different variable. So for example, instead of using a, I'm going to use m. And I know that the legs are equal to the key, which in this case, I'm going to use the variable m. And so I know that whatever m is, that's going to also be the value of a. And whatever m is, that's going to be the value of b. And then that 5 is just equal to m times the square root of 2. And so unfortunately in this problem, it's not so simple. I don't know the value of m yet. However, I do see that I have an equation here. The hypotenuse has to be whatever m is times the square root of 2, and they gave me the length of the hypotenuse. It's 5 in this case. So we can just do a little bit of arithmetic and solve for m here. Some books will actually make you rationalize this. I don't see a whole lot of point, but I'll show you how to do it. All that's saying is we don't want to have a denominator that is a radical. So if we multiply this by the square root of 2, the bottom by the square root of 2, then we just get 2 on the bottom, but we can only multiply by 1 and not change the value of something. So we're going to multiply the top by it as well. So we get 5 times the square root of 2 over 2. And that's the value of m, so I can replace the m or every other m in our diagram here with 5 times the square root of 2 over 2. And so you can do it that way. Again, this is also equal to 5 over the square root of 2. I'm personally totally fine with that. But it is good to know how to rationalize the denominator. Some standardized tests and things will require it. Again, that is a quick example of a technique of just using a formula or a diagram and transferring it over to a different example of that or applying that formula.